Alright, welcome to Mike Sword Academy. So today we are going to look at a question on capacitor where we want to calculate the energy stored in the capacitor. So we know that one of the functions of the capacitor is to store charges. So let's see how we can solve and calculate the energy stored in this capacitor. So we have a 1 microfarad capacitor that is charged using a constant current of 1.0 microampere for 20 seconds. What is the energy stored by the capacitor? So we want to get the energy stored by the capacitor, and we have different formulas we can use. So we can solve using W equal to half Q squared all over C as the work done in the capacitor or energy stored in the capacitor. So where you can see clearly from the question that the capacitance of the capacitor is given, but it seems like we don't have the charge, but we can calculate for the charge. So first of all, we have the capacitance of the capacitor as 1 microfarad, which is the same as 1 times 10 raised to the power minus 6 farad. So 10 raised to the power minus 6 is what we call the micro. And we have for the charge Q from our current electricity. We have that the charge is equal to the current times the time taken. So here we have the current. So the current is 1.0 microampere, which we are going to write as 1.0 times 10 raised to the power minus 6 because of the micro. So we have it ampere times the time. The time is 20 seconds, which is also in SI unit. So we leave it this way. Then multiply these two. We are going to have that 20 times 10 raised to the power minus 6 is the charge. And charge is measured in coulombs. So we write in coulombs as the charge. So now we have the energy stored is given with this formula. So that means that the energy or the work done is half, then Q. This time around we have the value of Q. So our Q is calculated as 20 times 10 raised to the power minus 6 as Q, then divide by C. So but remember the Q is squared, so we have to square it. Then we'll divide by C. C is 1 times 10 raised to the power minus 6. So that's our C. So now what you can see clearly is the 2 is going to affect your 20 and affect this. So we'll be having half times. So what we have now will be 20 squared, which is 400 times 10 raised to the power. The 2 will multiply with minus 6. So we have minus 12. Then we have 1 times 10 raised to the power minus 6. So if we should solve this, 2 is going to go with 400. So we have 200. So here the 10 raised to the power minus 6 will come up and become plus 6. And we have minus 6 in the solving. So what we have is 200 times 10 raised to the power minus 6. So that's what we have as the work done. So the work done is 200 times 10 raised to the power minus 6 joules. So that is the energy stored in the capacitor. So with this, we have been able to solve that. So if you are new to the channel, please subscribe to the channel and also click on the notification bell so that you get updates of different videos we'll be posting on physics, chemistry, and maths.